Right, if you're getting ready for your GCSE chemistry exams, you are in exactly the right place. Today, we're going to tackle a really crucial topic from the AQA spec, calculating gas volumes. Let's get you feeling prepped and totally confident for any questions they throw at you.
So, to kick things off, let's just focus on one single question. What is the one number, the one value, that unlocks pretty much every single gas volume calculation you're going to face at GCSE? Keep that question in your head, because by the end of this short explainer, you'll know it inside and out.
Okay, let's dive right in. Before we can even think about doing the math, we need to get our heads around one big, powerful idea that applies to all gases. Seriously, it doesn't matter what they are. This is the foundation for everything else that follows.
Now, this is the official rule straight from the textbook. It sounds a little formal, I know, but the idea behind it is actually really simple. Just remember, a mole is just a specific, huge number of particles. So what this rule is saying is, if you have 1 mole of hydrogen gas and 1 mole of oxygen gas, they're going to take up the exact same amount of space, as long as you keep the temperature and pressure the same.
So here's the crucial point. The identity of the gas, what it's actually made of, is completely irrelevant. It could be teeny tiny hydrogen molecules or much bigger carbon dioxide molecules. 1 mole of hydrogen and 1 mole of carbon dioxide will occupy the exact same volume. A great way to think about it is that a mole is just like a standard-sized container for any gas you can think of.
Right then, let's get back to that first question I asked you. It is time to reveal the magic number you need to know, and, more importantly, what it actually means.
And there it is, 24. Specifically 24 decimeters cubed, which, by the way, is the same as 24 liters. This is the magic number for all your GCSE gas calculations. Write it down, burn it into your memory. It is the key that unlocks this entire topic.
So what does this number actually represent? Well, 24 dm cubes is the volume of exactly 1 mole of any gas. But, and this is absolutely crucial, it only works under specific conditions. We call these room temperature and pressure, or just RTP. For your exam, all you need to know is that RTP means 20 degrees Celsius and 1 atmosphere of pressure. So as soon as you see RTP in a question, that's your signal, your cue to use the number 24.
Okay, so now we have our key number. Let's put it to work. We're going to look at the first type of calculation you're likely to face, converting a mass of a gas, in grams, into the volume it takes up.
Here's a classic example. You're given a mass in grams, and you're asked for a volume. Now, the key thing to realize is that you can't just jump straight from mass to volume. There's a vital intermediate step you have to take. And here's how you do it. Don't worry, it's a simple, logical process you can use every single time. First, you find the relative formula mass of your gas. Second, you use that number to turn your mass into moles. And finally, you use our magic number, 24, to convert those moles into a volume. Let's give it a go.
Okay, let's apply that method. Step 1. The relative formula mass, the MR, of CO2 is 44. Easy enough. Step 2. To find the moles, we just do mass divided by MR. So that's 11 divided by 44, which gives us 0.25 moles. And finally, step 3, we take our moles and multiply by 24. So 0.25 times 24 gives us our final answer, 6 decimeters cubed.
So that's how you deal with questions that give you a mess. But what if the question only talks about volumes? Well, this brings us to the second, and you'll be happy to hear, often much quicker type of calculation. This one is all about using the ratios from a balanced chemical equation.
And here is the best part. This is an incredible shortcut that is going to save you so much time in an exam. Because 1 mole of any gas takes up the same amount of space, those big balancing numbers in your equation, the mole ratios, they are also the volume ratios. This is amazing because it means you often don't even need to calculate the moles, which saves you a step and makes it less likely you'll make a mistake under pressure.
Just look at this example from the Haber process. We have 1 mole of nitrogen reacting with 3 moles of hydrogen. That's a 1:3 mole ratio. Now, if we translate that to volume, it means 24 decimeters cubed of nitrogen reacts with 72 decimeters cubed of hydrogen. And what's the ratio of 24 to 72? Yep, it's 1:3. The ratios are absolutely identical.
So, how does this actually help us in an exam? Well, let's take a look at this typical question. We're given a volume of one gas and asked to find the volume of another. And notice the units here are centimeters cubed. The brilliant thing about this ratio method is it doesn't matter what the unit is as long as you're consistent.
The method here is even simpler. First, and you absolutely cannot skip this part, you must have the correctly balanced equation. Then you just find the mole ratio from those big numbers in front of the formulas, and then you just apply that exact same ratio directly to the volumes.
Let's walk through it together. The balanced equation for methane burning shows that 1 CH4 reacts with 2 O2, so the mole ratio is 1 to 2. That means the volume ratio must also be 1 to 2. So if we start with 50 centimeters cubed of methane, we are going to need double that amount of oxygen. 50 times 2 gives us the answer 100 centimeters cubed. It's as simple as that. And because our starting volume was in centimeters cubed, our answer is in centimeters cubed too. Just as a side note, if you ever need to convert, remember there are 1,000 centimeters cubed in 1 decimeter cubed.
All right, we've covered a lot there pretty quickly, so let's pull it all together into a simple exam quick sheet. These are the absolute key takeaways you need to have locked in.
Think of this as your gas calculation toolkit. If a question gives you a mass, you use that two-step formula method. Convert the mass to moles, and then convert the moles to a volume using 24. If the question only gives you volumes, it's even easier. Just use the mole ratio straight from the balanced equation.
And honestly, that's pretty much it. You now have the fundamental rule of molar volume, you've got the magic number 24, and you've got the two key methods for smashing any of these exam questions. With these tools, you're not just revising anymore, you are getting ready to totally master gas calculations and bank those crucial marks.